All right, so we're going to walk through these. So a 4-kilogram ball is falling and experiences air resistance. It experiences an acceleration of 3.7. It should feel 9.8. It only feels 3.7. What's the friction force? So let's just draw that. So a 4-kilogram ball feels a weight force. Let's make it look like a W, Schmear. Weight force is M times G. So the mass is 4, G is 10. And so it feels 40 newtons of gravitational pull downwards. Now, has an acceleration of 3.7. That means that there's some force going upwards. So some force of friction. The question is, how big is that? Okay, so F net equals ma. So the mass is 4, the acceleration is 3.7. And so let's get my handy dandy calculator, and I get 4 times 3.7, 14.8. So the temptation will be right now to just be like, yay, 14.8, I got it. No, stop. Okay, no, 14.8 newtons is your net force. Okay, that is your net force. That net force tells you how different they are. Well, if it's 40 newtons going down and this guy's smaller, that means the friction force is 40 minus 14.8. Oh, just 35.2. No, 25. 25.2 newtons. Okay. Next up, you lift a 200 Newton box straight upwards with an acceleration of 1.5. All right, here we go. Box, 200 newtons. The mass will only be 20 kilograms. Because remember how weight equals m times g? We got to divide that g out. So if we have weight equals mg, I got 200 equals mass times g, which is 10 meters per second squared. So you get a mass of 20 kilograms. Okay. Look at what they give you in this one. They said, the acceleration, F net equals ma. So my mass is 20 kilograms. My acceleration is 1.5, so which is 30 newtons. So the answer, you don't just say 30, I'm done. Instead, you go 30 is the difference. Well, going back to our diagram, if it's 200 going down and I'm lifting the box upwards, I'm assuming it was written poorly, I wrote it, that you're starting from rest and lifting it. I could be wrong, but if you were starting it from rest and lifting it, that means how hard you are pulling, that normal force, called normal force, sometimes we'll call it a tension if there's a rope involved, but you could also say force applied. I think that one's pretty clean because it's like you applied a force. I don't care how you did it. I think that works pretty good. Force applied is going to be 30 more, so 230 newtons. Cheerio. Pip, pip.